have two colo centers, one on the West Coast, one on the East Coast. And the East Coast center was our, let's say, warm disaster site. And we just weren't comfortable that that gave us the kind of quick turnaround if something happened on the West Coast. We really wanted to move to an active environment so that we could use either the East Coast or the West Coast. And in fact, as business grew, we could even do geographic load balancing so that depending on your IP address, we might direct you to one colo site or the other, and that virtually eliminate any chance of extended downtime because of a problem at a particular facility. Well, when you want to have two colo sites, especially across the country, really work as one, where you have databases that have a database cluster that includes a database both on the East and the West Coast. You really have to have those connections work at LAN speed. And LAN speed is not just about the bandwidth. We have a gigabit connection between the two facilities. But on a LAN, you have virtually no latency. Your latency is measured in 1 or 2 or 3 microseconds. And when you have a latency of 70 microseconds coast to coast, which is still a very fast circuit, it can create a lot of problems, especially when you have applications that don't necessarily always use large packets. A lot of times they will instead have smaller packets with a back and forth conversation when they are communicating with stuff. And so we needed to get rid of that latency, and we needed to compress our data across that circuit. Well, as we looked at it, I'm a big fan of Occam's razor. And when I look at something, I do two things. I say, what is the most elegant, simplest solution that covers the broadest part of your problem? And also, can you take your problem and break it into smaller pieces that are more easily solved so that then the solution is even more robust? And in the case of WAN acceleration, you're fixing, if you will, the problem of the latency on the circuit. If you can turn that circuit into effectively a LAN speed circuit, then any application, any file transfer, any connectivity benefits from that. And then you can take and focus just on the problems of that particular application may have. For example, databases, having multiple copies in a database cluster. It has its own issues. Focus on that and not have to always worry about the network speed when you're focusing on that problem. And then it's a simpler solution. You can focus on the database problem. You can focus on the network problem. You can focus on a file transfer problem. And suddenly those problems are manageable and solvable. And at the end of the day, after you've solved them, your whole solution is there. We were very impressed with Infineta when we looked at it. We looked at a lot of WAN accelerators. And what we liked about Infineta was that, one, it was newer technology, really recognizing that this was, if you will, a network issue. It was built on network and switching architecture. As much as possible was put into hardware so that we could keep the latency introduced by the device at a minimum. And secondly, we really liked the fact that it could scale from 1 to 8 gigabits with just a software change, because we also have a 1 gigabit circuit between our two hosting facilities that is on a gigabit port that can also scale up to the 8 or 10 gigabits with just a software change. So we weren't looking at replacing the hardware or a limited investment if we grew. This investment would actually scale with our growth substantially. And so for the foreseeable future, we're not going to have to replace either the circuit or the device. We can just continue to upgrade it as our needs for more and more data transfer happen. And that makes that investment very, very leverageable.